Here I have a function h, and I'm going to first determine the vertex and whether or not that vertex is going to be a maximum or a minimum value for the function. And then I'm going to go ahead and write the equation for the axis of symmetry. So my function h has some fractions in here. And to find my vertex, well, it has an x-coordinate and a y-coordinate. In order to find the x-coordinate, I'm going to take the opposite of b over 2a. Remember that when my quadratic function is in standard form, my a is going to be my leading coefficient, and this b is going to be the coefficient of my linear term. Okay, so when I find my x value, it's going to be the opposite of b over 2a, which is the opposite of negative 5/3, so that will be a positive 5/3. And I'm going to divide that by 2a, so twice my leading coefficient. So twice my leading coefficient will be 2 times 2 is 4/3. Well, I have a complex fraction here, so let's go ahead and divide these. So 5/3 divided by 4/3 will turn into a multiplication problem where I'm going to multiply by the reciprocal, so 3/4. These 3's will cancel, so my x value here is going to be 5 over 4. So my x-coordinate for my vertex here is 5/4. So how can I go ahead and find the y-coordinate then? Well, I'm going to go ahead and plug the 5/4 into my function here. So h of 5/4. And I'm going to have some fraction business to tend to. So I'm going to say 2/3, and it's going to be times 5/4 squared minus 5/3 times 5/4, and then plus 7 over 24. Okay, so 5/4 squared is going to be 2/3 times 25 over 16. And let's go ahead and multiply straight across, so minus 25 over 12, and then plus 7 over 24. So here it's a matter of going ahead and doing this multiplication here. So I'm going to cancel this 2 with the 16, and I'm going to get 1 and 8. So I'm going to have 25 over 24 minus, let's go ahead and get these common denominators here of 24. So I'm going to multiply the top and bottom by 2. So minus 50 over 24 plus 7 over 24. Not so bad. So 25 minus 50 is negative 25, and negative 25 plus 7 is negative 18 over 24, which is pretty nice because that can reduce to negative 3/4. So my x value, or my x-coordinate of my vertex was 5/4. It looks like when I plug that in, my y value that I get for its output is negative 3/4. So let's go ahead and go back up here to the function. We'll write v for my vertex, and that guy is going to be 5/4 negative 3/4. Okay? So is that point, this vertex, is that a maximum or is that a minimum for the function? Well, let's go ahead and look at my leading coefficient, 2/3. This thing is positive, so I know my parabola is going to open upward, which means my vertex here is going to be a minimum value for my function. So this 5/4 negative 3/4 is a minimum. So let's go ahead and find the equation for the axis of symmetry. So recall that the axis of symmetry is going to be a nice vertical line that divides this parabola up into a left side and a right side. And the equation of this is going to be x equals the x value, which was 5/4. So my axis of symmetry has an equation x equals 5/4.